It's the final OSPF video. You never thought you'd get here, did you? Well, what I've done is taken all of the miscellaneous commands and features. They're the commands that I just couldn't figure out a place to fit anywhere else in the series and lumped them all together in one video. Now, I don't want you to think that since I couldn't figure out where to fit them, that they're not going to be useful. These commands are huge. They just don't really fit anywhere. Like, for instance, how to generate a default route into OSPF. We'll talk about that. We'll look at how to manipulate the external routes so that some look different than others and some add their cost differently than others. We'll look at how to change the formula that OSPF uses for its metric. I mean, all of these things are pretty key things. They're just kind of onesie twosies that get all tossed into this big conglomerate. So let's go ahead and get started. If you think back to EIGRP and how we configured authentication back then, you might remember that it was very robust, I guess is the good word. We could set up a keychain in global configuration mode that would automatically rotate keys on a date and time basis. Gave us a lot of flexibility with how we changed our keys out over time. OSPF is much simpler than that. It doesn't support that keychain concept. Rather, it supports a per interface authentication method. Meaning, I would go underneath my interface and type in the OSPF neighbors on this interface must supply this password. And all the neighbors that connect on that interface would have to have that same configuration. Once I do that, all communication between those neighbors are now password protected, meaning you have to supply that password in order to be accepted in the OSPF domain. Now, before iOS 12.0, it was much more difficult because it was on a per area basis. All the routers in the same area had to supply the same password. You can imagine what a nightmare that would be to change passwords because you could have 50 or 100 or more routers in an area that you would have to modify every so often to rotate those passwords. Now, OSPF supports two types of password authentication. It supports clear text or MD5. Of course, everybody today is using MD5. The only reason you would use that clear text or simple authentication is if you had a very old router that didn't support anything but that. The damage that can be done with that is tremendous, though, because somebody can sniff those packets and just see the password in plain clear text. Every single OSPF packet is keyed with the password. So once you turn this feature on, everything that you send, hellos, acknowledgments, replies, updates, everything are all going to have the password encoded inside the packet. If the router ever receives a packet from a neighbor that does not have the right password or a password in it, it will sever the neighbor relationship immediately and completely start from scratch all over again until that neighbor supplies the right password. Well, let me show you the configuration, and actually more than that, I'm going to show you how to troubleshoot OSPF authentication, because configuring is pretty easy. Troubleshooting, on the other hand, can get a little convoluted, so I want to walk you through that. I'm sitting right now on router 2, which is right in the middle. And actually, I want to be on router 3. Let's hop over there, because that's just a single relationship. It'll be less to look at with our debug messages. First thing I want to do, and the primary way to debug authentication issues is to do a debug IP OSPF adjacency. And that is not a shortcut. It's actually ADJ is the adjacency event. So that's as long as you can type it. So I've turned on that debug. I'm going to go under the interface that connects to router 2. And actually, let me just verify which interface that is. That is going to be serial 0/0.2 here. So I'm going to get into .2, and I'm going to type in IP OSPF authentication, and then I have the option to either type in authentication key, or I can type in authentication and what type of authentication I want to configure. Now, how we type this in depends on what sort of authentication we want to use. If we type in authentication key, it's going to assume that we're using plain text authentication. It's a little convoluted, if you will, because it's just saying, well, it's a key, right? Well, an authentication key is one thing, but a message digest key is the other. So let me show you the difference. We have IP OSPF. I guess you could say there's 3 commands that do this. IP-OSPF authentication turns on one method or the other. You can either type in IP-OSPF authentication and hit enter, and at that point you're doing plain clear text simple authentication, or I can type in IP-OSPF authentication message digest and I'm doing hashed authentication. That's the first command. The second command depends on what kind of authentication we want to use. If I type in authentication key and then my passcode, I'll type in Cisco, that's going to assume it's a plain text or simple authentication. If I want to do hashed authentication, I'll type in IP-OSPF message digest key. Isn't that a kicker? And I can type in what key ID I want, and I can put up to 255 different keys that are accepted, if you will. It's kind of like a keychain system, but there's no date and times. It just says, I will accept all these keys. So we'll say message digest key 1, MD5, and then I can type in my key right there. So 3 different commands. Let's go ahead and let's use simple authentication to start off with. I'll type in IP-OSPF authentication and just hit the enter key. That now requires simple authentication. I'm going to follow that up with IP-OSPF authentication key, and then I get to type in my passcode and whatever I want that to be. Now you can see, I'm glad I didn't type that in yet, because as of right now, we just had our neighbor relationship go down. You can see that it says received packet from this, that's our neighbor, on this interface, mismatch in authentication type. Input packet specified type 0, we use type 1. Now regardless of whether you're using simple or MD5 password authentication, it will always say either type 0 or type 1. And there, our neighbor relationship just died because it missed 4 hello messages. Type 0 means there is no authentication. Type 1 means that there is. So if you're trying to troubleshoot, if you see one side using type 0, that means they are not using authentication at all. So I'll finish this up by typing in the authentication key of Cisco, and I'll turn off that debug. Use space all. Now I'm going to hop over to router 2. And on router 2, let me just do a show IP interface brief. And sure enough, we have this interface, serial 1.3, that connects to router 3. So I'm going to, let's do a debug IP OSPF adjacency over here so we can watch things happen. Now I typed in the key of Cisco over there, right? Yeah, I just want to make sure. So I'm going to come over here to router 2 and go into interface serial 1.3. Now you can see this side, the flip message, it says, hey, they're using type 1, we're using type 0, which indicates we're not using authentication. So I'm going to type in IP-OSPF authentication and just hit enter at that point to turn on the simple authentication on this interface. Now I want you to see what message we receive. It says, now I'm not using type 0, meaning I'm allowing the authentication to happen, but there's now a mismatch in the key, as in they have one and I don't. So I need to go in here and type in IP-OSPF authentication key and type in that same key of Cisco. As soon as I do that, the keys now match. And when the next hello packet comes across, these two are going to say, hey, this is great. We can speak, and wham, neighbor relationship is born and routes are exchanged. That's how you turn on the simple authentication. I like doing that because it's a little simpler, no pun intended, than taking a look at the MD5 authentication. MD5 is exactly the same thing. You just type in the authentication and follow that up with message digest, and instead of typing an authentication key, you type in that message digest key. Just start off with key 1 and type in the MD5 keyword and whatever password you want to use, and at that point you specified a hashed key that it will use rather than the plain text. Otherwise the process is exactly the same. The next miscellaneous topic I want to talk to you about is OSPF external route types. OSPF, anytime it sends routes in from the outside world, marks them as external. So all the routers know that these were generated by the ASBRs. There's those LSA type 5s. But there's 2 different kinds of external markings OSPF can give them. One is an E1 marking, which is where the cost of the route increments as it passes through the autonomous system. The second and the default is an E2 marking, where the cost of the route remains the same as it passes through the autonomous system. I'd like to show this to you because it's much better to demonstrate it and have you see it and go, aha, than it is just to talk about it in theory and you'll quickly forget it. Take a look at this. I'm sitting on router 3, which as of right now is connected to a RIP network and the OSPF network. I'm going to type in show IP route on router 3, and sure enough, it's got some OSPF routes and some routes that it's learned via RIP. Now I want to send those RIP routes into OSPF, so I'm going to get under the process and type in redistribute RIP, and I'm going to do the subnets of RIP so it doesn't just send one classful route, although I guess that is the classful routes of that. So either way, that keyword didn't matter. I'm going to specify the metric for those routes, and it shows the cost as being 100. So I'm going to start them off when they come into the system as being a cost of 100. The next question it asks is, what is the metric type? Now, if I just hit the Enter key, it's going to assume E2, the defaults. But for now, I'm going to type in, I want a metric type of E1, external type 1. Now, when I hit question mark, you can see my options are dwindling down. Until we get into the redistribution officially, I'll leave these two a mystery. I'll just hit the Enter key to send those into the system. Now, these costs do accurately reflect how much the links cost. So when I get to router 2, let's check that. I'm going to jump over to router 2 and see if it received those routes. Show IP route and hit Enter. And sure enough, it looks like I've got all of those routes, and each one of them is costing 140, which makes sense because that's the 100 that I chose to redistribute them with, plus the 40 that the link costs on the way there. Now, if I jumped over to router 1, I'd assume that they would also be, I don't know, what's 140 plus 64? That would be 204, right? So let's do a show IP route over here. And sure enough, Jeremy's math in his head works. 204 is what the cost is of all those routes. That is because they are marked as external type 1 routes. Now, the alternative and the default is external type 2. That is what I would recommend in most circumstances. That's why it's the default, because most of the time when you're talking about your link to an external network, there's only one router that can get you there. So when you do this, let me jump back over to, whoops, can't do Control-Shift-6X on a slide. Jump back over to router 3. I'm going to undo that redistribution command and then redo it with a type of 2. Now you can see it's sending them in as a metric of 100. Now let's hop over to router 2, do a show IP route, and notice the metric is 20. 20, which I have no idea why that's the metric. Let's hop over to router 1, show IP route, and it's 100. Now this is making no sense at all. Hang on, let me go back to router 2. Show IP route. All right. That was strange things occurring with OSPF. You saw that. You saw it here first, right? We were sitting on router 2. It said 20. So I'm guessing, I don't know what I'm guessing about that, but it's fixed itself. So now it is 100, and that's what I expected to see. As soon as we specify 100 on router 3, that 100 will stay the same the whole way through the system. And that's because, you know, the advantage of doing that is since there's only one exit point in the whole network, why make the SPF algorithm have to add all this stuff up when it doesn't matter? There's only one way to get there anyhow. So here's the point. External type 2 is the best to use when you have a single exit point to, in this case, our RIP network. If you have multiple exit points, though, that's where you want to use external type 1, because without that, it's not going to be able to calculate what the best path really is, because both of them will stay the same through the entire autonomous system. Now let's move into adjusting the OSPF costs. In that last demonstration, I showed you that the cost of those RIP networks were 100, then it gained 40, and it gained 64. Now, many of you may remember that OSPF gathers its cost, that cost estimate, based on a formula. It is the bandwidth in megabits per second divided into 100, or you could say 100 divided by the bandwidth in megabits per second. Now, that is what gives us our values that you see on the screen. However, there's a little bit easier way that we can adjust that cost. If we know what we want the cost to be, and we don't want to fool with this formula and putting in different bandwidth amounts and adjusting it and all that, you can overrule the formula. All you need to do is go under the interface. I'll go under, in this case, interface serial 0.2, and just type in the command IP-OSPF cost and whatever you want the value to be. It's that simple. No formulas, no dividing. You just type in the cost, and that will be what the cost is on that interface. It overrules whatever formula was in place already. But let's say you do want to use the formula. Most people do, so they don't have to type in the cost on every single interface, and just let it be accurately calculated based on the bandwidth. As we mentioned way back in the concepts videos for OSPF, we said the links nowadays have gotten faster than 100 megabits per second. They've gone to gigabit or 10 gigabit or soon to be 100 gigabit per second Ethernet. Now, any of those values plugged into this formula will result in a cost of 1. It sees them all as fast Ethernet interfaces because it can't have a fraction for a metric. So with that in mind, how do you fix it? The command is simple, but the ramifications are huge. What you want to do, if you want to fix the formula, is to go under the router OSPF process and type in the command auto cost space reference bandwidth, and then whatever you want that top number to be. Now, right now, that top number is 100, which means 100 megabits per second is the maximum speed. So if you were going to adjust this, I'd probably adjust it big. Meaning you might be thinking, oh, well, the fastest link I have right now is gigabit, so make it 1,000. That would make gigabit a cost of 1, fast Ethernet a cost of 10, and so on. But what's going to happen in a couple years? Well, 10 gig, 100 gig, 1,000 gig Ethernet. Who knows what else is going to come out? It's going to blow our socks off, and then we're going to have to all go back to this formula and change it all around. So why not, while you're doing this, make a one-time adjustment, just jump in there and go crazy. It's going to be a while before they start topping 100 gigabit per second. So maybe 100 gig is how big you make it. Maybe you jump into 1,000 gig per second range. That would be awesome. So whatever that number is, you need to make sure that number is the same on all of your routers. That's what I was talking about, how the command is simple, but the ramifications are huge. Because if you type in that command on just router 1 and leave it the same on router 2 and 3, well, then router 1 is going to be advertising some insanely large metrics that are going to throw router 2 and 3 way off. And they're going to think router 1's got some horrible routes. And same thing, router 1's going to receive the routes from 2 and 3 and think that they've got some amazing routes because the metrics are so small because it's using the old formula. So an adjustment to that formula is a network-wide change. This next miscellaneous feature is one that Cisco added in very recent years. As a matter of fact, I had to use my production router to demonstrate this one because none of my other routers supported it. It came out in iOS release 12.37T, so it was an experimental train and really went mainstream in the 12.4 iOS releases. What it is a method that can prevent the link state database overload. LSAs are tough to process. The SPF algorithm runs constantly, ups your processor time, and eats up a lot of your router's resources anytime a bunch of LSAs are sent. So Cisco said, why not put in a command that can allow you to limit the number of LSAs that are received by the router? Now, I'm going to show you this command and then explain its ramifications. They're pretty devastating unless you tweak this command. It is known as the max LSA command. Let me bring it up here. I'm on my router. I'm going to type in, I'm under the OSPF router process. You just type in max dash LSA, and then you can type in the maximum number of generated or non-self-generated, just LSAs, that this process can receive from its neighbors. So maybe, you know, we're wild and we want to limit this to 100 LSAs. Now this is in a per minute basis. So if it receives 100 LSAs in 60 seconds, and you can see if I can just hit enter here, what it will do is it will kill all of the neighbors. All neighbors go down for 5 minutes. It's like a 5-minute penalty where it's going to ignore all the LSAs and then come back online after 5 minutes. Wow. Can we say devastation? Because as soon as that happens, I mean, if that was like a router 2, the network just went down for 5 minutes because it's like, oh, sorry, too many LSAs, my friends. I'm going to ignore you. So I would seriously consider tweaking this command if at all using it. First off, you can see that once we reach a certain percentage, it can generate a warning message. So maybe at 20%, I want to receive a warning message. Now, what I would use this command for, I have never used this command in production. It scares me too much. But what I would use this command for maybe is the warning only. And that one allows it to not kill the neighbor relationships. It will just generate warnings anytime the max LSAs are received. And I could actually just remove the 20% because warning only will just generate a message anytime we get up to 100 LSAs per minute. Now, all of these other times are timers that we can set up for how long to ignore. This is the ignore time, which is how long I will ignore the neighbors after we've exceeded the maximum number of LSAs. That by default is 5 minutes. So it's going to say 5 minutes is how long I'm going to wait once I've received that before I will start reestablishing my neighbor relationships. The ignore count is how many times it can go into the ignore state, meaning that ignore trigger can start before it just says, that's it, I'm down permanently. Can you see how devastating this command is? If I were to type in max LSA 100 and then type in ignore count 2, what will happen is it will go through a cycle. If it receives 100 LSAs in 1 minute, wham, ignores once, you know, for 5 minutes, everybody's down. Comes back online, receives another 100 LSAs within a minute, and goes down the second time. As soon as it goes down and ignores its neighbors the second time, it stays down. As in the OSPF process, never kicks back in again until administrator comes on there and restarts the process using that clear IP OSPF process. Oh, holy cow. That's why I stay away from this command. The reset time, last one in here, is how long it's going to consider until it resets the ignore counters. Meaning, by default, by the way, this is 10 minutes, which says I will wait, you know, if I receive 2 ignore messages within 10 minutes, I'm going to consider this process down. I'm going to completely kill this. But maybe I receive 1 ignore and I ignore all my neighbors for a certain amount of time. Then I come back online and then another ignore happens an hour later. Well, thankfully, the reset time allows that one an hour later to be a separate session, if you will. It doesn't go against this ignore count of 2. This last miscellaneous OSPF command would be the one that I would consider to be the most important command of this whole section. And the reason I say that is this is the command that allows OSPF to send a default route to the whole domain. It's one you will end up always using in the real world. In this case, router 3 has a connection to the internet. Router 2 and router 1 connect to other networks that use router 3 for its internet connection. Now, as of right now, I'll just do a show IP route. You can see that router 2 does not have any default route. Gateway of last resort is not set. And router 3, I'll do a show IP route here, does. You can see that I have a static route as of right now to my emulated internet out on null 0. So either way, regardless of where it's going, this is a default route that allows it to get to the internet. So we need to have a way to allow OSPF to send that default route to all of my other routers in the scene. The command is simple. All I do is go under the OSPF process and type in default information originate. That command causes the OSPF router to generate a default route if one exists in its routing table. Let me show you. I'm going to go into router 3, router OSPF 1. get into that process and type in default information. Oh, it's actually dash information originate. As soon as I do that, I jump over to router 2 and do a show IP route. And it should have suddenly this E2, you can see an external type 2 route saying all of my information, all of my default route information goes through router 3. That is the default for the network. Router 1 propagates that on all the way to the end of area 1, and it can see that it also has a default route out now as well. Now, the catch with default information originate is that it will only advertise one as long as router 3 has one in its routing table. If I were to go back and remove its static route, here's the command I put in there to add the static route. Now, router 3 does not have a default route, and that means neither does router 2 or router 1. It removes that default route from everybody because router 3's went down. Now, that makes sense sometimes. Maybe you want router 3 to always generate a default route, regardless of whether it has a default route or not. Maybe it has other network connections that it's not advertising that aren't a default route, but you figure that I just wanted to send a default route to everybody else, so I don't have to advertise all those individual networks. Well, in that case, all you do is go to router 3, or whatever router you have that is generating that default route, and type in default information originate, and now you want to tack on always. Always says always advertise that default route, even if you don't have one. If you want to change the type of route, you can see it chooses E2 by default, or what metric it uses for its default route. You can do that from here as well. But now if I go to router 2 and do a show IP route, it will have a default route in its table, even though router 3 does not have one. So a plethora of miscellaneous and handy options that we can use with OSPF. Some of them are really useful, like the authentication. Well, you know what? Just about all of them could be really useful, depending on your situation. Some of them might be a little dangerous, like that new prevention of the link state database overload, the max LSAs. Yikes. That one I'd probably stay away from. But we did walk through the authentication options, looking at the simple and MD5 methods. We looked at the external route types. External type 1 keeps adding up the cost of the external routes all the way through, whereas external type 2, the default, just maintains one cost the whole way. We then saw manually adjusting the OSPF cost metric using the IP OSPF cost command under the interface, and adjusting the whole formula with the auto cost reference bandwidth command. Last couple we looked at was the link state database overload max LSA command, brand new command that is scary in my opinion. And then finally, the default route information generation using the default information originate. I hope this has been informative for you, and I'd like to thank you for viewing.